d dot s. Okay, what is the physical meaning of this? You take some imaginary closed surface like this, okay, because this is like a open surface is there, but it is formed by the closed line. It is formed by the closed line. Okay, now what I was telling, you choose some value here, some random point, some random surface. Okay, some random surface. Once we choose, see, okay, choosing some random point here. Okay, anyway, because of some rotational nature of my field, maybe f. Okay, I may get my del cross f here. We don't know. We may or may not get. It all depends on the field nature. Okay, suppose because once if this is making rotation in this manner, definitely your vector will be in a perpendicular direction. Okay, it's all depend on how it is rotating in a particular place, how your vector is rotating. Okay, your del cross f will be in this direction. And again, once if you have chosen some surface here, you have chosen some surface. See, I will put it in a red color. I have chosen some surface. Definitely, for the surface vector will be in this direction only. ds vector. Okay, that is a surface vector for that surface. Already del cross f is coming. Now we are having ds vector. You know both the direction. Both are in same direction. For example, both are in same direction. Now what will happen? Just you take a dot product. You will get the maximum value. Okay, you will get the maximum value because both are in same direction. Okay, once if del cross f and ds are in same direction, that means angle is 0, you will get a maximum value. Okay, you will get a maximum value. Or in some other case, say for example, um, for example, see, this is your ds. Anyway, you taken that surface, but because of the field nature, okay, uh, your your del cross f is in this direction. It is possible. It all depends on how your f is behaving, your field. Okay, del cross f may be in this direction. In this case, what? It's not exactly perpendicular. Okay, it is making some angle. Okay, it's making some angle. There is some angle. Now, what is the field nature? What is the final answer depends on? It depends on you are getting del cross f some value. That's okay, and you know ds vector. It simply gives a direction generally. A ds vector, and again ds, and again it depends on a theta value. At what angle your del cross f with ds. Okay, if theta is 0, definitely you will get the maximum value. If theta is 90°, what is the meaning? They are exactly perpendicular. Your del cross f and your surface vector is exactly perpendicular. Then you will get a 0 value. You will get a 0 value. Okay, now I take some realistic case. Then I will see. We will see what is our answer, because at this point we know only the nature of the electric field. Okay, anyway, within 10 minutes I will complete this. Okay, we know the nature of the electric field. Okay, say the electric field will go in a linear direction. Say if this is going in this way. Okay, so this is an electric field. Okay, this is the electric field. Once if it goes in this direction, okay, in this direction. Now, what will be your del cross E? What will be your del cross E? Yes. See, once if electric field is going in this direction, from our understanding, del cross E is 0. From our understanding, del cross E is 0. That means what? Your del cross, you will not form any del cross E at all. Okay, del cross E is 0. Okay, del cross E is 0. So finally your answer is 0. Okay, you take any surface. Okay, you take any surface, finally your answer will be 0, because your del cross E itself 0. Okay, once because your electric field itself is not having a rotational nature. It is not having a rotational nature. Once it is not having a rotational nature, it cannot produce any del cross E. Once if it is 0, you take any surface, okay, irrespective of the surface where you are, okay, your answer will be 0. Okay, you go around all the surfaces, you choose any surface, you will not get any component. You will not get any component. That is the idea. So finally you will get 0. Because once again, already we have seen once see, you can relate with the line integral also. You can relate this with the line integral. Okay, what is actually happening here? You take this line integral. Already field is there. You take the line integral value. Okay, you go along this way. You are going this way, this way, this way. Finally, you are reaching here, or otherwise you go there and finally you reach here. Okay, anyway, you have to reach your final position. Finally, what is the work done by you is zero only. See, even if you calculate this into dl in this line, you go along your closed line. Generally, we will not take this. We will be taking this. Okay, that edges. This is the closed line. Okay, this is a closed line for your open surface. Okay, you calculate the integral e dot dl with this line. Finally, definitely it will be zero because your vector is going only in this direction. Your vector is going only in this direction. Then finally your answer will be zero. Okay, that is observation we have already seen. Even from the surface integral point of view, you are getting the same value. You are getting the same value. Now, uh, I will change this. Okay. Now, instead of this way, okay. Now I take some field. I take some field that is making rotation in this manner. I have taken some field that is making rotation. See, this is your dl path. See, if you want to calculate that dl integral e dot dl, say if this is, say for a realistic case, this is the magnetic field. Okay, any field. Okay, I'm taking as a magnetic field because magnetic field will have this nature. Once if you make integral h dot dl, definitely you will get some answer because this is also going in this direction. You are also going in that way only. See, at any point of time, you take E vector nature and dl, there is a possibility that you will get some answer because the dot product of this one and with this one is exactly same because both are going in the same direction. Okay, this is also in the rotation nature. This is also in the rotation nature. Once if we do the mathematics for this, definitely you will get, yeah, you will get what, sir? You will get some value. You will get some value. See, for example, you take a field like this. This is the field value. This is your path. You try to calculate this. Definitely, you will get some answer. That is the idea here. That is the idea here. Okay. So, and again, how it is working in the surface domain. How it is working in the surface domain. Once if it is having a rotational nature, once if it is having a rotational nature, okay. Uh, See, once if it is having a rotational nature, based on the rotational nature, it will give you some del cross H. Okay, it's having a rotational nature. Okay, as it is having a rotational nature, definitely depending on the angle it is, what angle it is making rotation, definitely it will give some del cross. What's that? Some del cross H. Okay, it will give some del cross H. Okay, and again you choose some surface. For that surface, definitely there will be some dz, ds. Okay, surface vector, and again your surface vector and your del cross h. Del cross h is having some value ds based on the theta between these two surfaces. You will get finally answer. You will get final answer. Again, please, what you are doing, you are integrating over all the surface. See, I am choosing only one surface, but what actually you have to do? You have to choose all the surfaces on this one. You have to choose all the lateral surfaces. You have to choose. Finally, what is the answer? Okay, finally, what is the answer? Okay, in this case, definitely we will get some answer because it is having a rotational nature. Even once if it is a rotational nature, integral E dot del is will have some value. Why it is having some value? Once if it is a rotational nature, del cross E will have some value because once there is rotation, del cross E will have some value, either positive or negative. Okay, then finally either you can go by this procedure or you can go by this procedure. This is the idea of the Stokes theorem. Okay, this is the idea of the given a vector, the effectiveness of the vector on somebody. Say for example, if it is an electric field, if the some random unit positive charge is moving anywhere on the universe, then what is that effect of electric field on that charge can be calculated with help of closed line integral or open surface integral. Okay, open surface integral. This is the idea behind the Stokes theorem. This is the idea behind the Stokes theorem. In the next class, we will see what is the divergence theorem and what is the significant meaning of the divergence theorem. Okay, please, at the end of the day, please remember it connects the line integral closed line integral with the surface integral, closed line integral with the surface integral. And again, you should be very clear with what is actually dot, what is ds. Ds means what, sir? It is a surface vector. Okay, because you are putting dot product means it is very clear that ds is not a scalar, ds is a vector. Then what vector? Surface vector. So see, how can you write any vector surface vector? See, if it is a surface ds, they are telling like this means how you can write actually ds is ds into n cap, because ds itself is will have some value, say r square sin theta, like that. Okay, you have chosen some surface. On that surface, what is variable, what is constant? Then you should know what is that direction of vector. For example, surface vector means n cap, a vector that is perpendicular to that surface. Okay, a vector that is perpendicular to the surface. If in a case, if a sphere, if you have chosen some point, some small area on the sphere, then what is constant? R is constant. Then what is constant? R is constant. Then with the help of remaining things, what is variable? Theta is variable, pi is variable. Once with theta is variable, r theta. If pi is variable, r sin theta d pi, r sin theta d pi. So instead of d, as you have to replace with this. Then n cap comes. In this case, what is n cap? For a spherical, in a spherical coordinate system, what is n cap? ar cap, radial, a radial vector that is going radially outward from the center point, ar cap. This is the idea. Okay, so with this I will close. We'll see you on tomorrow. Bye. Yes, any doubt finally?